Okay, so let's begin our lecture with the yesterday's problem that we have started. We have started with the problem like an RCC roof slab of overall size 6500 mm by 3000 mm and thickness 150 mm is provided with 12 mm diameter main bars which are bent up alternatively along the shorter span and placed 150 mm center to center, while the distribution steel is of 6 mm diameter bar which is kept along the longer span and is provided at 200 mm center to center. The clear cover for this particular slab is 15 mm. So for this particular problem, we have to find out the quantity of steel and we have to prepare the bar bending schedule for this same. Now we have started with the problem. Our first step is nothing but to find out the length of main bar. Now, as far as this particular plan is considered, again I will draw the plan for you, a simple plan. Okay, this particular, from this point to this point, the length is your 6500 mm, that is our longer span, and from this point to this point, this is our shorter span. Okay, yesterday we have drawn the diagram also. So main bars are arranged, or these are with respect to the shorter span. Okay, like this, your main bars, and these are your distribution bars in the horizontal direction. Okay, so at first we have to calculate the length of main bar. What is the formula that I am going to use? The length of the main bar equals to the total length minus clear cover, which is provided from both the side, plus 18 into diameter of the bar plus 0.42 d, plus 0.42 d, where d is nothing but the depth of the slab. A capital D is nothing but depth of slab minus top cover minus bottom cover, or it is nothing but depth of slab minus clear cover, difference of clear cover. Okay, and small d is nothing but the diameter of the bar. You have put the values of the total length along the shorter span. Total length is 3000 mm minus clear cover, it is provided 15 mm on either side, that is 30 mm from both the sides. So 2 multiplied by 15, that is 30, plus 18 into diameter of the bar is 12 mm along the, that is along the shorter span. We are having the main bars, bent up bars, which are bent up alternatively, plus this additional length is nothing but 0.42 d, where d is nothing but the depth of slab minus clear cover. Total depth of slab, it is given as 150 mm in the problem. Okay, 150 mm depth of the slab which is being provided. So 150 minus 2 into clear cover, you will get the this value of capital D. That comes as the total length of main bar comes as 3236.4 mm, and length of straight bar, that is along the long direction, the bars which we have kept, these are not bent up, these are straight bars, just hooked it. Okay, so total length is nothing but clear cover, total length minus clear cover plus 18 into diameter of the bar. Okay, so total length is along the longer span, total length is 6500 mm minus clear cover is 2 into 15 plus 18 into diameter of bar is 6 mm. So 18 into 6, that next length that we are getting is nothing but 6578 mm. After this, what is our next step? Our next step is nothing but finding out the number of main bars. Our next step is nothing but finding out, I will write for everyone, finding out number of main bars. What is the formula to find out the number of main bars? Anyone? Number of main bars. As we are finding out the number of main bars, our formula becomes length of longer span minus clear cover. I will write in shorter just for the understanding purpose. Okay. Okay. First I will draw this. Length of the longer span minus clear cover curly bracket complete, divided by spacing of shorter span plus 1. Okay, so this is the formula that you have to use for finding out the number of main bars. Now main bars are kept like this. Okay, you can see the pointer which I am pointing. Okay, the main bars are kept in this particular direction. So formula to find out the number of main bars equals to length of the longer span minus clear cover divided by spacing of the shorter span plus 1, and vice versa formula we have to use for finding out the number of straight bars. Okay, now if you consider this problem, our calculation becomes length of this longer span is given as 6500 minus clear cover is 30. Okay, minus clear cover is 30, bracket complete, divided by spacing of the shorter span. Now if you read the problem, this the slab is provided with a 10 mm diameter main bar bent up alternatively along a shorter span and placed 150 mm center to center. That means spacing of the shorter span is 150 mm. Okay, whole bracket complete plus 1. Tell me how many number of main bars. Tell me how many number of main bars. Please solve the problem and tell me the answer. Meanwhile, I will proceed for the next one. Finding out number of straight bars. Length of shorter span. Minus clear cover divided by spacing longer span complete plus 1. Tell me the answer. That is number of main bars. You just put the values and tell me the answer. What is the number of main bars? How many number of main bars are there and how many number of straight bars are there? Just give me the answer for the same. Give me the answers, finding out the number of main bars and number of the straight bars. Give me the answer. Do the calculations, very simple one. What is the number of main bars? Anyone, please? Okay, main bars are 44.13, that is around 45 numbers. Okay, of the main bars. And what about the straight bars? What about the straight bars? Do the calculations fast. Number of straight bars. Okay. So number of straight bars will be how many number of straight bars? Have you find it out the answer? Please respond. Number of straight bars. What will be the calculation for the straight bars? Finding out the number of straight bar. Length of shortest span is 3000. Correct. Minus 30. That is our spacing. Hmm? Sorry. Clear cover difference divided by spacing of the longer span. It is 200. I think it is 200 plus 1. So if you solve the equation, you will get you the answer comes as, I think somebody has quoted the answer, 15.85. Uh, yes, your answer is correct. 15.85. That is around 16 number of bars. You require 16 numbers of the bar. After finding out this, getting this particular bar, our next step is to prepare the bar bending schedule. So bar bending schedule, you have to give the title like this: bar bending schedule. Okay, in that bar bending schedule you have to insert the I will draw the table for you. Okay, so that you will have some idea how many number of rows. 1 2 3 4 5 6 7. Okay, 7 by 3. Okay, so you have to draw the table with me, and this is the standard format of the table. The first column will be nothing but your serial number. Second column will be your description. Third column will be your numbers, number of bars. Okay, fourth column will be nothing but length. Fifth column will be your total length. Sixth column will be your weight, and last column will be your total weight. Okay. Okay, so in this way you have to prepare the table for the bar bending schedule, final bar bending schedule. Serial number 1 will be your description is nothing but your main bar. Okay, main bars. You can draw the diagram also. You can add one column, that is shape of the bar, and you can draw the diagram also in this particular table. If not, it is also okay. Main bars, how many number of main bars are? 45 numbers. Okay, length of the main bar. What is the length of main bar that we are having? Length of main bar equals to 3236.4. 3236.4. Length we are going to take in mm. Okay, then total length will be, how you are going to calculate the total length? Total length nothing but, here I will write the formula. Total length is nothing but numbers numbers multiplied by length. Okay, so number multiplied by length, that means this column number 3 multiplied by column number 4, you will get the total length. Okay, you will get the total length. Then weight of the bar. What is the diameter of the bar? Diameter of bar is 12 mm. So weight of the bar equals to, what is the formula that we are going to use for determining the weight of the bar? Equals to d square. Correct? That is, I will write it as just a minute. D square divided by 162. So this is our formula. Okay, weight of the bar equals to d square. Huh? This is square. Hmm? D square by 162. I will just take a minute. Mm, the formula is known to you, that is d square by 162. I'm just finding that formula, but I'm not getting. And total weight is nothing but total weight is nothing but total length multiplied by the weight. Okay, total weight is nothing but total length multiplied by weight. WEIGHT. Okay. Okay, so in this fashion you have to put the values. What will be the total length? Total length is nothing but, you can take it in mm or you can take it in meter, also in meters. This is in mm, huh? So you can convert it in meter. So if you do the calculation, if you do the calculation 3 point, what is that length, 236, that is meter, multiplied by 45, total length in meters will be equals to 145.62 meters. Okay, then weight of the bar, it is d square by 162, that is 144 divided by 162, it is point 0, sorry, 0.88. Okay, it is 0.88. hmm? Then total weight is nothing but 0.88 multiplied by 145.62, that comes as 145.62, that comes as 129.44 kg. Okay, you can write in this fashion also. Okay, so similarly you have to do it for your straight bars. Number of bars will be 16. Length of the straight bar equals to, what is the length that comes, 6.578. Okay, I will write both in meters, not in mm, so there will be no confusion to you. Okay, 3.236. Okay, this length is 6.578 mm, 6.578 meters. Total length will be equals to, take the multiplication of both, that is 16 multiplied by 6.578, that comes as 105.248. Yes, 105.24. Okay, then next, weight of the bar equals to, what is the formula for weight of the bar, what is the diameter of the bar, diameter of bar is just 6 mm. Okay, so 6 mm, that means, what is the formula to determine that, weight of the bar equals to d square by 162, that is d is 6, so d square is 36, 36 divided by 162, that is 0.22. Okay, kg per meter, that is weight of the bar. And last column, that is total weight is nothing but total length multiplied by weight. Total length is 105.24 multiplied by your 0.22, so your answer becomes 23.38 kg. Okay, 23.38 kg. I will take this in the next page so that you will have some. Yes, so are you able to see this column? Okay, 23.386. And here you can also add the last column as total weight. Okay, in the last column you can take the summation of both, that is 129.44 129.44 plus 23.38, that comes as 152.82 kg. So this is the total steel that is required for that particular slab. Okay, this is nothing but the total steel which is required for that particular slab. In this fashion, here you can also add one column also after description, that is nothing but the sorry, two columns you can add over here, that is as diameter of the bar and shape of the bar. You can add or you cannot, means you can do whatever simple for you. Okay, so this is nothing but the bar bending schedule. Okay, are you getting how I have solved this particular problem? So that I will give you the next problem to solve. Have you noted the problem? Please note down the problem in the notebook so that we will proceed for the next problem. Okay, please note, take a note of this particular problem in your notebook. I will give you 5 minutes to write it down so that we will proceed further and we will discuss another problem. Please note down this problem in your notebook. If you have completed, then please tell me. We will then proceed further. We will discuss next problem. Please note down the problem. You can take the screenshot also so that I will proceed further. I will give you the two problems to solve. If you are noted, then I will give you the next problem. Have you prepared this bar bending schedule? Please take a screenshot of this and you can copy it in your notebook also. Meanwhile, if anyone is having any difficulty, you can ask me. If you are having any difficulty, you can ask me. Less than 1 minute is left to conclude this session. So if the session ends, please rejoin the session immediately, so that we will